All right, last thing to learn. Adding and subtracting rational expressions. I have a very redundant statement right here. I'm going to start off by saying that the square root of a minus the square root of b is the same as the square root of a minus the square root of b. In other words, I cannot combine meaning addition or subtraction, I cannot combine radical expressions if they are not identical. All right? So for example, the square root of 3 plus the square root of 5, that cannot be combined. That's just square root of 3 plus square root of 5. If you're tempted to think that that's equal to the square root of 8, type it into Desmos and you'll see that the square root of 8 has a different value than the square root of 3 plus the square root of 5. Okay? So I'll start that with a warning. You cannot combine radical expressions unless the radicals are the same. Let's see what that looks like. So here's a tough looking problem. 4 times the square root of 96 minus 10 times the square root of 24. There's nothing that you can add or subtract at this point. I cannot say 96 minus 24 because the radicals are not the same. Right? You can test that out for yourself. Right? I cannot say 4 minus 10 because these are not like terms. So I cannot subtract. Can't do anything except for going into each individual expression and simplifying it the way that I learned in the first half of the notes. So 4 roots of 96. I can change my root 96 into root 16 times root 6. All right? Strategic. I chose a perfect square that would fit into 96. Not only a perfect square, but the largest perfect square. You have a question? Okay. Oh, I stretched you. Okay. And that's important. If you immediately go into, well, my factors could be, 2 and 48. So that's good and everything, but 48 contains a perfect square that factors into it, so you would have to continue working. All right? You want to choose the largest possible perfect square that fits into the number. All right? Again, that's review from the first half of the lesson. So square root of 96 is really the square root of 16 times the square root of 6. All right, I'm going to do the same thing with my square root of 24. The square root of 24 is really the square root of 4 times the square root of 6. All right, that's how factoring a radical works. Okay, so now I'm going to simplify my perfect squares. The square root of 16 is 4. The square root of 4 is 2. So I'm going to rewrite my expression now with a 4 and with a 2. The most common mistake that I see students make is they will tell me that the square root of 16 is somehow equal to the square root of 4. And that is false. All right? That is false. The square root of 16 cannot possibly be equal to the square root of 4. All right? It is equal to 4. Just like the square root of 4 is equal to 2. Okay? Now I'm going to see what I can multiply. Well, 4 times 4 is 16. And 10 times 2 is 20. So now I have 16 root 6 minus 20 root 6. This worked out really, really nicely because both of my radicals are a square root of 6. So now at this point you can combine like terms. Think of these guys like variables. If this expression said 16x minus 20x, we would combine the like terms by subtracting the coefficients. All right, so that's exactly what I'm going to do. I'm going to subtract my coefficients. So 16 minus 20 is negative 4 quantities of root 6. Okay, so my final answer right there, negative 4 root 6. Again, see how I'm entering each step along the way in a cell on Desmos where it tells me that my value is correct, that it is correct. So that's that. Summary, if your radicals are identical, then you can combine the coefficients, all right? Just like terms, okay?